Okay, so this is the 2012 micro free response question number 2. Go ahead and pause the question here, try to work on it and solve it. This is about consumer choice, and then you can play to see my solution. So we're told that Teresa consumes bagels and toy cars. We're given the marginal utility she gets from both of these, and in part A they want us to use the marginal utilities given for cars to calculate her total utility from purchasing 3 toy cars. So in that case you would need to add the marginal utility provided by each of the first 3. So 10 and 8 would be 18, and 18 plus 6 is equal to 24. So 24 would represent her total utility when she purchases 3 cars. In the next part of the question it says that her income is $11, the price of bagels is 2, the price of toy cars is 1. What quantity of bagels and toy cars will maximize Teresa's utility if she spends her entire income on bagels and toy cars? And explain your answer using marginal analysis. So what I've done is redraw the table, and we're going to keep in mind that she's got $11 to spend. Again, we were told that the price of bagels was $2 and toy cars was $1. And we want to remember that we know that the consumer maximizes their utility when they consume, so that the marginal utility of bagels or any other good divided by the price of bagels should be equal to the marginal utility of toy cars or any other item divided by the price of toy cars. So marginal utility per dollar, 8 divided by 2 would be 4, 3.5, 3, 2.5, 2, 1.5. Over here, because it's $1, they all stay exactly the same. And so she wants to buy, she has $11 to spend at $2 a pop. We see that buying a toy car, you know, at $10, at $10, margin utility is 10 utils per dollar for the first toy car. So that has the highest, and that would reduce her $10 budget down to 10. She again looks for the highest utility per dollar. Again, it's a toy car at 8, so that takes her down. Now she's spent another $1, so she's down to 9. Again, the marginal utility per dollar for the cars is 6 compared to the first bagel provides 4, so she's going to buy another toy car, so that means she's down to $8. And now 4 and 4 are the same. We can go ahead and continue and buy another toy car to make 7, but then we're going to buy our first bagel because it costs $2. 7 minus 2 takes us down to 5. The second bagel gives 3.5 utils per dollar, and the fifth car rather only gives 3. So we're going to buy another bagel. So that cost us another $2, so that takes us to 3. And then the fifth car and the third bagel both give us 1 util per dollar, so that takes us to 2. And then another bagel takes us to 0. So Teresa has spent all of her $11, and she in the process bought 3 bagels and 5 toy cars. And notice that the marginal utility per dollar, the last $1 spent on cars, provided the exact same amount of marginal utility as the last dollar spent on bagels. They were both equal to 3. The part B of question number 2 tells us to assume that wheat, which is an input for bagels, increases in price. Since wheat is an input and the price of the input has gone up, it will not affect Teresa's demand for bagels. The demand for bagels is only affected by those prime factors, right? Demand shifts. So the change here would actually be a negative change, a decrease in the supply of bagels. The supply curve would shift. Let me just show you real quick. Hold on. Okay, so I'm back in the market for bagels. This would be supply. This would be demand. Our original equilibrium price and quantity. And as we were saying just a moment ago, increase in the price of an input causes supply to decrease or shift to the left, and that would bring about the change in market equilibrium noted here. We would have a higher equilibrium price and a smaller or lower equilibrium quantity. So the thing is that the change in supply is represented by a shift. There is a change in the quantity demanded, right? Because as a result of the new higher equilibrium price, there will be a smaller quantity demanded. But as far as a change or shift of the demand curve, that didn't happen. In C, we are asked or told that Teresa's income elasticity for bagels is negative 0.2. Does the value of Teresa's income elasticity indicate that bagels are normal goods, inferior goods, substitutes, or complements? So what you should recall is, of course, that we have a number of different elasticities. We have the price elasticity of demand, price elasticity of supply, the cross-price elasticity, and income elasticity. They're identifying income elasticity. Income elasticity has to do with how a change, a percentage change in income affects the percentage change in the quantity demanded. So how does a change in income affect the quantity demanded? And when we look at income elasticities, the most important thing is the sign, right? So if this whole thing is a fraction that is greater than 1, right, that means that the quantity was affected by a positive change by the change in income. So in other words, it's positive, and so a positive or direct relationship exists when the good is a normal good. Incomes go up, so do the quantity demanded, and if it is less than 1, then the change or sign is negative, and negative signs mean that the good has a negative or inverse relationship, and that would be inferior. So your income rises, you actually demand less. Your income falls, you demand more. But in this case, it was a positive change, and therefore, oh no, sorry, it says that her income elasticity is negative 0.2. So at negative 0.2, the negative value means that bagels are an inferior good, and the substitutes complements things. That's a distractor. That's if we had been asked to consider the cross-price elasticity, but but that's not part of this question. Part D, however, does get into cross-price elasticity, and cross-price is all about changing the price of one thing. How does the percentage change in the price of one thing, A, affect the percentage change in the quantity demanded of another item, B. So again, it's the sign that's important. If it's a direct and positive relationship, then we say they are substitutes. If it's a negative sign, we say they are complements. Because if we increase the price and that causes an increase in the demand for the other thing, then both signs are positive, hence substitutes. Or if they were both negative, then the signs result in a positive overall sign. The inverse relationship is when we raise the price and that causes a decrease, or we decrease the price and it causes the other thing to increase. So in this case, we said that, or they say that there is a price increase of 10% for cars. She buys 5% fewer cars and 4% less of blocks, so minus 4% blocks. And so we were supposed to calculate the cross-price elasticity between toy cars and blocks and whether or not it's positive or negative. So we can already see that it's negative, and since the price change was on the bottom, toy cars price changed by 10%, and it caused a decrease of 4% in toy blocks. The overall sign is negative, and it is 0.4. Whew, that was a long one, but we're done now.